Hi everyone, myself Krish Raithukam, very warm welcome to all, and this is day 16 of Foundation AI series. So in this day we're talking about little bit mathematical concept as PCA that referred to that stand for like principal component analysis, and we look toward the lots of important concept around it that we should to understand. And previously we discussed lots of mathematical concept as an abstract idea, but I will try to in all this particular video to connecting all this particular real world application to understand you much better. But again, I also try for this particular video also, and again. Uh, we're discussing lots of mathematical concept, and I think like next 10 days is going on mathematical concept. Because of that, mathematics is important for artificial intelligence. It is very necessary to discuss. So we're discussing only for idea without going to derivation, formulas, anything else. We are not going to discuss formula and anything particular manual like particular formula to doing itself. I will try to explain you what the idea behind it saying, and try to connect this all this particular idea, abstract idea, to real world application, to like how can you just understand this particular thing, like how actually work in this real world application. So again, if this particular video is going to productive for you and if you learn something for that, then it's my pleasure. And overall agenda for today is like the first like PCA that I will give you a little bit introduction about PCA, what is the PCA and how actually PCA work in machine learning, deep learning, and artificial intelligence, like entire subsets of the artificial intelligence. Okay, and second is a real world application. I will try to connect all this particular concept, abstract concept, mathematical abstract concept, with the real world application to understand you much better about PCA. So let's get ready for this, and let's start. Hey, let's come to agenda number 1, and in this agenda we're talking about like PCA. So that's really interesting to discuss, and what the idea behind the PCA that I will try to explain. So the first of all, PCA stand for the principal component analysis. So that's refer to some components are basically designed by like also the data. Okay, so that's create confusion. I will try to explain a simple word. I give a 3 word to explain entire structure of the PCA. First, simplify, separate, and visualize. Okay, how it's work. Now suppose you have a large data sets and large context of information. Okay, but you want to train this particular data, like your model, with that kinds of the information. Okay, but the problem is here is like your model are overfeeding this particular information, and they take a lots of, and you are not going to visualize this. Okay, now suppose you have a large context of data and they arrange in such way like you are not just plotting. Like now suppose let me come to understand this particular thing with example. uh, Now suppose we have a 3 parameter. Okay, so like this is a mouse 1, mouse 2, and mouse 3. I think I try to predict a genetic code. Okay, okay, so this is the 3 mouse. Okay, mouse 1, mouse 2, mouse 3. Okay, this mouse 4. Okay, and this is gene 1, gene 2. This is 2 gene. We are discussing about all this particular genes of the all this mouses, like mouse 1, mouse 2, mouse 3, mouse 4. Okay, there are 4 mouses. How can you visualize this particular data? You are simply plot this particular data in like a graph, but how can you add a dimension on this particular data? Now suppose the first, if you want to entire graph, like entire data in that particular one graph to visualizing this, then I think it's look like something 1 dimension, 2 dimension, 3 dimension, m1, m2, m3. M3 is third coordinate. What about fourth? How can you represent this particular fourth coordinate? The fourth coordinate, where is there were 3 coordinates, you visualize it, but fourth one, where you can going to where are you actually add this particular fourth one? The best way is like PCA solve this particular problem. Like PCA help us to understand like the analysis the entire data structure, now 3, 4, 5, 6, 7, 8, and they arrange this entire data structure in such way like they adding the information in like 2 components, PC1 and PC2. PC1 capture the variance of the data, like all the variance of data, like you can say either in the forms of the dots and all this particular variance of the data. This is the they capture large variance of data, and they capture the non-related data. The PC1 now suppose entire data sets are arranged in a 2 dimension, reducing without losing the information. Okay, like reducing the dimension Now suppose if we want to like plot this particular thing in, like we need to lots of dimension because there are lots of parameter and lots of features. Okay, so in that cases of the PCA says that the idea behind the PCA is all about reducing the dimension and give only for entire information context will be changed into two dimensions, PC1 and PC2. PC1 contain all the variance data and PC2 contain non-variant data. Okay, now suppose this PC1 and PC2, the entire lots of adding lots of dimension, reducing the dimensions from all this particular data sets, and just convert into the two dimension PC1 PC2. Okay, so that's the idea behind it. Why this particular idea is important? Because of that, when model want to train, okay, when you are training a particular model like artificial intelligence model, machine learning model, and like neural network, so it's depend upon the how you are training a model, like what kind of data. So entire, now suppose if you are training a model like predicting a price of the house price, lots of parameters of matters here. Give lots of data sets like temperature, neighborhood, location, and so on, like lots of parameter, but few of them are important. Okay, so model using the PCA idea, like PCA method, to convert the entire data sets into two dimensions by looking toward the variance of data, the plotting the data into a two dimensions in such way like without losing the information. So that's all about the idea behind the PCA. So PCA is all about principal component analysis, and they analyzes the all this particular data, simplify the large context of data, and they separate according to the importance. Okay, and that are helpful to visualize. Okay, so that is very helpful for visualizing. Because of that, when you're plotting a data in lots of different dimensions, I like 100 to 200 dimensions, most like as we know, the high dimensional space we added in the machine learning framework, and as we know, machine learning is using high dimensional spaces and all this particular stuff. Okay, that's pretty interesting to know about that. What idea, like what amazing idea. Like PCA introduced in 91. Okay, 1991, I think 1991, and that solved the machine learning problem. Uh, because of that, when particular engineer tried to predict something and they learn from the making a model to learn from the data, they have a lots of dimension. So reducing the how actually PCA work, the PCA work, they center the entire data. Now suppose like this particular data, okay, they center the entire data set like near to zero, and finding the average relationship between them, all of them, like how much this particular data like how much distance of this data. Now suppose they keep the data near to zero, all this particular data near to zero, and find out the relationship between both of them, looking toward a difference from the zero, how much they different from the zero. Okay, both of direction, they're comparing this all this particular data by such as few difference in there by like zero. So that's all about it. So first they center the data, second they calculate the variance, so how much the data are different from each other. Like now suppose the two data, like now suppose this is a particular model and there were lots of spots. Okay, okay, look this, they looked at how much this particular data point is different from this one, and they calculate the variance and analyze, and they're finding the PCA1 PC2 and arrange this particular variance according to the PCA1 PC2. Okay, finding PCA1 PC2, arrange this particular component in PCA1 PC2. Second, dimension reduction, they reduce the dimension, they are using the important information and they reduce the information which are not useful. Okay, so without losing the information, the simple idea behind the PCA is all about the without losing information, they summarize all the data in two component. Okay, instead of looking toward the adding a large high space dimensions, like a high dimensions. Okay, and that is very helpful to visualize, and the use cases is here like data visualization, and second one is noise filtering model is actually using it, and image comparison. So there are use cases of the particular PCA, and entire structure of the PCA is basically designed to reducing the reduction noise from the data. So it's all about like lots of data are not very important, so we're reducing the data and we capture only for important data. Because of that, and this is very important to reducing the memory size, and because of that unwanted data, why we using unwanted data, we only use important data to train our model, so that also reduce the noise. So that's all about a PCA. And again, I will try to explain this particular thing. And let's come to agenda number 2 to explain this, understand this particular thing as a real world application. Okay. Hey, let's come to the agenda number 2. And in this agenda, we're talking about real world application. And as a promise, I will try to connect this PCA concept with this particular real world application to explain you like how actually PCA works. So let's come to understand. PCA refer to like principal component analysis. And again, I will try to explain you like PCA is all about something reducing a dimension and giving the entire context of data in a such as reducing a dimension to like two different information, to adding a two different information to without losing the information. They added two dimension and separating the entire data in such a two dimension. Okay, so that's all about it. So let's come to the real world application. The real world application is your Snapchat AR. Snapchat basically developed the meta developed this Snapchat, and the interesting part is like Snapchat have an AR facility. It facilitates AR refer to augmented reality, which is a mixture of their something real world to something like virtually and something like. So in Snapchat using a filters like some blurry and some like blurry image and some lots of filter there, but I don't know what the names are. But sometimes you are using emojis in your face and all this particular thing. So how actually Snapchat AR using this particular PCA to generating an image for your image. Okay. So now suppose in Snapchat you are using you want to just blurry image. Then what happened and how the PCA help. Uh, so let's come to understand. Snapchat using the filter method to just like PCA method to understanding the data. And entire context of data, they differentiate the data in two different principal components, PCA1, PCA2, and then after they regenerate the image, your blurry image. So now suppose your blurry image is like something, you give an image, you click an image, and your image is like clear, okay? And image is all about data, and this particular image take a AR model of this particular Snapchat into form of the pixel data, the entire matrix of the pixel data. This is a pixel matrix, okay, of your entire image information, where is a most important variance of the data, like entire image is converted into pixel matrix. Okay, so that is information of image in numerical form, in short. And taking this data and plotting into dimensions, okay, and finding the two dimension by using a PCA method like PCA1 and PCA2. So PCA1 says that to entire matrix of the data converted into two different dimensions, they reduced all the dimension of data and give it two different contexts. The first PCA1 and PCA2. PCA1 take a dominating pattern to understand the which part of the image have a more dominating features, something like brightness, edge, and something like structure. So understanding your structure of the face. PCA1. Second thing like PCA2. Other important patterns like which is less important pattern, but highest important pattern are taken as something in this particular space. PCA1 and PCA2 contain contrast variations, like where is a high contrast particular data is, where is the high contrast of your image, where is low contrast, and they understand the entire pattern in the two different dimensions instead of adding a different dimensions, high dimensional spaces. Okay, and the important part is like they reduce a memory, and the model are trained very frequently and very easily without any noise, and they regenerate your image by adjusting a value like particular pixel. Now suppose if you want to clear, want to make a particular blurry image, then they understand entire part of your structure of the image by PCA and by particular method, and they understand which part you want to blur and which feature need to blur, and they blur a particular image by adjusting the pixel. So that's all about like real application of PCA. PCA is all about something reducing all the dimension and giving a two different dimensions of the entire dimensional space, like high dimensional space converted into two dimensional space is all about PCA. PCA1 containing a high variance data, PCA2 containing next high variance data. So here in Snapchat is using PCA1, PCA2. PCA1 contain brightness, edge, where is a more brightness in the image, like some like in your head, some shadows and some edge, your facial structure they capture by two different dimensions. Okay, so that's tricky to understand, but when you try to understand like particular thing but real world application, this is much easier to understand you. And that's all about PCA. So again, I repeat, the PCA is all about something, principal component analysis. PCA is all about something, you can say, reducing high dimension space into two dimension, like a fewer dimension, looking toward important features without losing information. So here, entire contrast of the data, entire data sets, we are not losing any information, okay, and converted into two variants, PCA1 and PCA2. And the model continue with training a particular cell and predict the right image, what to add, which part you need to blur, either in your head side, either in the forehead, where either in the like below the nose, and something here. So that's all about Snapchat AR. It's basically designed on PCA, and the PCA logic work here. The idea of PCA, again, idea of the PCA is all about reducing high dimensional spaces in like few dimensions, looking toward without losing the information. So that's all about PCA. Okay. Uh, Again, if this particular video is going to productive for you and if you learn something from there, then it's my pleasure. So thanks for watching. See you soon.